In this lesson, we shall focus on applied mathematics, APM 3711. We shall be looking at the modified Euler method. Right, question 1. As indicated previously, that this question here actually appeared in a November examination. So it appeared in November 2023. And we want to look at what had to be done in this particular question here. Use the modified Euler method with the change in t equals 1, right? And with two corrections. One correction, one recorrection per step to find x at 1 and y at 1 for the initial value problem. Right, but now there are two things we need to actually look at here. Two corrections are necessary. We'll perform one correction, and after which we will actually perform a recorrection. It is our first time in our the series of our discussions to look at these particular questions. And so to start, we need to look at the algorithm. Right, need to look at the algorithm. What is the algorithm? Right, the algorithm contains what you call the predictor. And at this point, the predictor becomes exactly the following. What is the predictor formula? The predictor formula is given by y predictor. And y predictor is the same as what? It's the same as y sub I plus h f x sub I, y sub I. And this is the formula we use for the predictor. But in view of the fact that it is the modified Euler, we remember this one is the first order Taylor series. And now it becomes the Euler method. So the predictor is the Euler method. The predictor becomes the Euler method. But it doesn't go alone because the modified Euler, then we have the corrector. Right, the corrector. Y corrector. yi plus 1/2 h. Right, and we then have fx sub I, y sub I, plus f x sub I, h, yp. So we have yi plus 1, which is y sub I plus 1/2 h xi yi plus f xi plus h yc1 close bracket. So now there are two formulas. So we actually analyze the algorithm we need to use here for the modified Euler. Okay, often these questions repeat, and if they ask the modified Euler, then this is what we use. But in particular, because there are two conditions given, there have to be two corrections. So one correction and a recorrection. So now, if the predictor is y sub p equals to this one here, then the corrector will be actually the first correction, one correction, which is this one here. And then you're going to do another correction. How do the two corrections differ? You are able to see that in the last argument, right, the last argument is the predictor. And then the last argument of the second correction, of the recorrection, the last argument becomes the first correction there. And this is the algorithm we use for the modified Euler. And therefore, we are in a position to to begin solving this problem using this algorithm here, and we start as follows. Now, there are a couple of things, obviously, that one must think about here to actually solve this particular problem. And we must actually, therefore, be very, very pedantic in as far as we solve this. Right, so now we then say by using modified, the modified Euler, right, we continue by using the modified Euler method, right, with the change in the variable t equal to 1. So we continue. And now, what then do? We set the scene and we prepare ourselves. So we're gonna say, for example, because there are two systems here, or there are two equations. So now we need to give a name to the first one. But if you look at the fact that in this case, we actually call the first one F. So we shall call the first one F, and then we shall call the next one G. Right, so this is what we do. So then we actually gonna say dx dt, we're gonna call it F, x, y, in the same way that we have xy, and then we put the t there, like so. X at t0 is x0. dy dt. G y t0 is y0. Okay, we introduce precisely this particular notation here. Right, so we actually introduce this notation, and actually introducing this notation allows us to be in a position to solve this particular problem in a very organized manner. Right, with this in mind, we actually, therefore, because there are two equations, yeah, dx dt, we call it f of x, y, and t. dy dt, dy dt, this one, dy dt, right, dy dt, we call it g. Okay, now with this, then we continue to analyze this in detail, and we're gonna actually look at the fact that there are two differential equations, and therefore we need to have two predictor equations. And so the predictor becomes the following. So if this one is called F, this one is called fxyt, gxyt. Then we have the predictor. So that in this case, if you look very carefully here, we'll come back to this. The predictor, we actually have a different name for it. So we're going to call it, for instance, the YP. And now the corrector, we're going to actually call it exactly the YI plus 1. But in the same way, there are some notations we can actually sort of use here to make sure that we're able to get the same result. For example, we're going to adopt a new notation that says we can call this one y I plus 1 comma p. Okay, because this is yi plus 1. So you can call it yi plus 1 comma p. With that mentioned, for the predictor, because it is x, we can call it xi plus 1 comma p. So that is going to be exactly xi plus h. We called this one f. So we're going to have x I yi. Yes, x I yi. And then we shall actually introduce a new variable there. And now we actually obviously can be in a position to think about that very carefully in the way we can introduce it. And so if this is xi, yi, we can call this one t. We can call that one t there. Okay, let us continue with our analysis of this particular problem. And then now we're going to have y, because this one is y, I plus 1 predictor, yi plus h, g, xi, yi, t. Right. So now we then have the following. We'll then have exactly the following there. Right, we then have exactly the following. We then have exactly the following. So if we want, we can introduce, which I think is the best thing to do. We can introduce I for the variable t. Is t itself is subject to a couple of changes. So we can actually have exactly that there. Right, in line with our notation. After having done this, we're going to introduce another variable, another set of equations we call the corrector equations. Right, and the corrector equations, we're going to write them in red. Two corrector equations. When I have x, because it is x there. Right, and now because there are actually exactly two corrections, what then we're going to do is we're going to have we can write them like so. We can say it is xi plus 1 corrector, and it is going to be exactly the same as xi plus h over 2 in brackets f of xi yi ti. We add f of, right. So in the same way, I want us to use exactly this set of equations. So we'd have, for instance, for the first correction, you're going to have xi, yi, a ti as well. Then here we're going to have, for instance, an xi with h, and then we're going to have the yp. We're going to have the yp. Right, so that is what we need to actually take note of there. And so, because you're going to have the yp, you can have exactly the following there. So you're going to have xi plus 1. Right, you're going to have exactly xi plus 1. And after that, you're supposed to have a yp. So now, for the yp, we're going to introduce the following variable. We're going to have yi plus 1p. And then obviously you're going to have exactly x. You're going to have x and then y, correct. X and then y. So now at this point, I want us to look at the fact that we're going to have xi plus 1p from here. And the predictor for the y as well. And then we're going to have our fact that the change in t is 1. So we can have ti plus 1. And then now we continue to have the y I plus 1 corrector. Right, for the second correction, or because obviously we're dealing with the x and y system. So dealing with the correctors here, you have the correction for x and similarly the correction for y. So given that the predictor for y is this, we'll have the correction for y. And it's going to be just pretty much like the x. But it will have the variable y in it. So we have exactly that. But yeah, the y is g. So it's going to be g, xi, yi, ti. Plus g. You want to have x I plus 1p predictor, y I plus 1 predictor, ti plus 1. Okay. Exactly that way there. We continue to then say, in view of this we've written, right, given the initial value problem, given the initial value problem as dx dt, which is t plus x minus y. Right, and what exactly are you going to have here? What you're going to have is that these here, we called it f, x, y, t. Simultaneously, x0 is 1. That way, dy dt is y minus x squared, which is exactly a g xyt y at 0 is 0. Right, so now there are a couple of things that remain important here. We speak about the predictor. So let us speak about the predictor a little bit more in detail. Now we start with 0, 0. Both x and y have the argument 0, so it means therefore that t0, because you're speaking about ti, so that now t0 is 0. T1 is 1. If this is the case, the change in t will therefore be 1, because it is like a t1 minus a t0, right? So it is like a t1 minus the previous. So 1 minus 0, it's a 1. So the change in t is 1. Okay. Speaking about the predictor still, would remember that we have just said that the predictor xi plus 1, predictor xi plus h f xi yi ti. Let us perform some substitutions to be able to get, for instance, the next thing we actually need here. If we want to get x1 predictor, which you can write as x at 1 predictor, it is the same as the following. Right, it becomes the same as x0, right, because I is 0. So 0 plus 1 is 1. Then we have x0. And then we have h, f of x sub 0, y sub 0, t sub 0, like so. What is x sub 0? X at 0. Okay, because x sub 0 for us is the same as x at 0. What is x at 0? It is exactly a 1 plus. Okay, so let us do something. You see, sometimes we're using h, which is okay because we're used to h, but we can use delta t for the question, for this question. H is delta t. So you can use delta t, like so. Now let us continue with our computation. Delta t is 1. And then you have f, this. What is f? If this one is fxyt, okay, f is t plus x minus y. So we're going to have t0. What is t0? It's 0. Because its argument, it's 0. Right, and then we add x. What is x0? X0 is a 1. And then we have what? We have also minus. So put the minus here. y0. y0, it's a 0. This is 1 times 1. 1 plus 1 is what? Is 2. That gives us the first value for the predictor. But also we have found the one for x, but we must this has 2 equations, so we must be able to find the one for y also. Y1 predictor. Okay, continue, please. So Y1 for the predictor, Okay, so obviously to get y1 for the predictor, let us write a little bit the general equation for y. The general equation for y. What is the general equation for y? Right, so the general equation for y for the predictor is as follows. So it is yi plus 1 predictor, which is exactly the same as the following. So you have y plus 1 predictor, which is yi plus h. Right, so you have g. Okay, yeah, but we can use, as indicated for h, you can use delta t, same thing. So whenever you use h, it's the same as the change in t. And then we're going to use the y. Y goes with what we called g, x, y, t. Okay, y we called g, x we called f. Okay, so now we continue with the y, which we called g. So it's going to have a g here. And it's going to be a delta t, then with the g, xi, yi, ti. This is it. So y1 pay, which is y0. So, right, so it's going to be y0 delta t, like we've written here. And then it's going to be g of, according to this thing here. Okay, we are making I0 to get y1. So it's going to be gx0, y0. And then it's going to be t what? T0. Right, so what is y0? Y0 is like, for us, when you say y0 is the same as y at 0, and y evaluated at 0 becomes 0, according to this. So we're going to put a 0 here, plus delta t is a 1. We're going to put a 1. The g, the g, so now this, it's going to be what? According to this, it's going to be y0 minus, so you're going to have y0 minus x0 squared, like this. What is y0? It's 0. X0 is 1. So you're going to have 1, 0 minus 1 squared. So we have this. Right. So we continue. We continue. Okay, so we have this. So we have exactly this. So now, this one is a minus 1. Yeah? It is exactly a minus 1. So we got the two predictor values. For x, it is 2. For y, it is negative 1. Okay, those are the two predictor values. Okay, then we continue to do the the corrector, and then the recorrection. First, let us do the one correction and then recorrection. Right, so now we're going to start by looking at the, first, let us look at the corrector, and then we shall look at the correction after. Okay, so let us write the following. Right, because the way we stated the corrector. So this corrector is going to have xi plus 1. Xi plus. Yeah, we can put h, because the formula is normally h, but h is delta t in this question, so we can have that. But yeah, we put h. And then we have the following. So we have f. So this is fxyt, and then this one is gxyt. It's our choice of the functions. So now we're gonna use the choices. Now, let's look at the corrector. So it's gonna be h over 2. Then we have x, xi, yi. Then what? Ti plus f. So it means, therefore, you're gonna have the xi plus 1 predictor, yi plus 1 predictor. So we have that. So we have yi plus 1. So we have yi plus 1. So you have xi, yi, ti. So now, okay, we continue with our g. For the y goes with g, and it is gx I plus 1 predictor, and then yi plus 1 predictor, and then ti plus 1. Okay, this way, because of the change in 1. Can write like that. Now, in the same way that the ti plus 1 can be looked at like this, because it's just one step ahead. One step ahead. Because the change is 1. And, but strictly speaking, can write it in the same way, like we're putting the subscripts there. So we can write and make it a subscript. But of course, the next step is 1. Of course, the next step is 1, but this is more accurate. Now, at this point, we have the following. Let us deal with the corrector for the x and the y. Right, so we're going to deal with x1 corrector, which you can write as x at 1 corrector. And according to this, it's going to be the same as x0. Change in t, which is f x0, y0, t0. So X1 predictor, Y1 predictor, T1. Okay. What is this? What is this? Because the H is the same as delta T. What is X0? We substitute everything here. X0 is 1. Delta T is 1. So now, okay, so let's look at the F. F is what? F X Y T is T plus X minus Y. So we're going to have X0. And what is X0? It's 1. And then we add X. We add yeah. So we first start with T0. Right. But now we know very well T0 is what? We know that T0 is the beginning, which is 0. We've already said. So T X Y. Right. T0 is 0 there. So you're going to have T0 here, which is 0. And then we add X to it. X0, 1. And then we minus Y0, 0. So now with F again, but it has X1 predictor, it has Y1 predictor, which we've got, and then it has also the T1 as well. Let us check. What did we get? X1 predictor. Right now, X1 predictor, we got it as what? As 2. X1 predictor is 2. So we put a 2 there. Right, so we come here and XY predictor, because now we're looking at the F. It starts with a T. But obviously looking at that, what would T1 be? T1. T1 is 1. We've already said that one. And then now, dealing with the function F here, we have T, and then we actually look at X. So we're going to have the X predictor. X1 predictor, 2. Put 2 there. X1 predictor, you put 2 there, 2. Minus Y1 predictor. Y1 predictor is minus 1. Y1 predictor, minus 1. Right, so you have Y1 predictor, minus 1. Oh, okay, because we are following Tx minus Y. Okay, but now we're going to have minus. You're going to have minus, minus. Check this out. So you're going to have a minus, minus. Okay, the formula says you must minus. You must subtract Y. But what is Y predictor? Y1 predictor. We got it to be what? We got it to be minus 1. So you're going to have the minus 1 there. Like so. Okay. And so now, if this is what we have, this is what we have exactly. This is what we have. Okay. So now, okay, so this is 0, 0. 1 plus 1 is 2. Plus 2 is 4. Plus 1 is 5. Okay, 1, 2, 3, 5. 1, 2, 3, 5 out of 2. Plus 1, 7 out of 2. which you can write as 3.5. 3.5. 1 plus 1 is 2, plus 1 is 3, 3 plus 2 is 5, and then you have 5 over 2. 5 over 2 is like a 2.5. You add 1, which is a 3.5. Okay, good. So now this is what we've got. Let us get the next one. So the next one is going to be the y. So it's going to be y1 corrector. y1c. Right, so you have these, then you put the g's. T0. Okay, we are using the y subscript I plus 1, this one. And then we're going to have g x1 predictor, y1 predictor, t1. Okay, we continue. So according to this formula here, it's going to become what? We're going to do it in red color to create a difference between the above and the one below. Y0. It's 0. Delta t, it's a 1 out of 2. G, here is G. G is y minus x squared. So it's going to be y0, 0. Minus x squared. So minus x squared. So we continue. Right. We continue. We continue. So, okay. Right. So we have the 1/2 there. Then we're going to have the g, but the g is y minus x squared. So it's going to be y0 minus x0 squared. Y0 is 0, and then x0, x0 squared. X0 is 1 squared. So that's going to be 1 squared. So now we have this one. We have this one. Okay, we continue. What is gx1 predictor, y1 predictor, t1? Okay, so we put the x1 predictor. So this one is going to just, it has no t, so it is y minus x squared. So it's going to be y1 predictor minus x1 predictor squared. So you square the x1 for the predictor. But let's deal with the y1 for the predictor. Right, y1 for the predictor is minus 1. Right, so you're going to do y1 for the predictor. Yeah, for this one for the g. So it's minus 1 minus x1 predictor squared. X1 predictor. X1 predictor is 2. X1 predictor is 2. Yeah, but you square it. Minus x squared. So it's 2 squared. So it's exactly 2 squared. Like this. What is the answer to everything we've got here? So now, okay, so you know that the squares are on the numbers. Let's see exactly what we've got. So you have the squares on the x. If you write carefully, so this is going to be like 1 squared. Just write some brackets around this to make sure that we think clearly. And then also the square is on the 2. It does not affect the minus. Okay, it does not affect the minus. So now at this point, then you have what? You have minus 1, minus 1, minus 2. Okay. Minus 2, minus 4, minus 2, minus 4 is minus 6 divided by 2, minus 3, minus 3. Minus 1 is minus 2. Minus 2 minus 4 is minus 6. You divide by 2, you get a minus 3. That's what we've got. So this one is the first, is the corrector. Then, but we must do two corrections. So we're going to do also a recorrection. Let us look at a recorrection for this problem. Recorrection. Okay. Now, to be able to do the recorrection, we actually need to consider the formulas we have written and take note of the fact that this step is the successor step of the former. And therefore, we use the following formula. xi plus 1 corrector. Right, corrector. Can be seen as xi plus h over 2 fxi yi ti plus f. Now you come to this one. So these arguments are the same, but they go one step ahead. But these arguments, they come from the former things. So these arguments will become x plus 1 predictor. They'll come from the previous things. Right, so if this is the case, yeah, so they come from these because you've already had a corrector, so they will come from the corrector. So you're gonna have xi plus 1 corrector, and then because the recorrection, and then yi plus 1 corrector. So that is what we're gonna do because we use the predictor. Now we're gonna use the first correction. So you're gonna put a correction here. So you can do as many corrections as you want. Here they said you must do a recorrection, so you must do like 2 corrections. So we double these. So but we must use the previous values. So we're gonna have I plus 1 correction. Then we're gonna have ti plus 1 like this. Okay, so let us deal with this one. But now let us write the next equation. So we're gonna have yi plus 1, which is, okay, continue. And then it's gonna become y sub I, the h over 2, which is the same as delta t in the question, but the formula normally uses h. So we actually obviously can switch between the two notations. Okay, but like we said before, the y is our g, it's xyt, fxyt. Okay, so you're gonna need g. We're gonna need g. All right, so in other words, you're gonna have, yeah, okay, let's look at this one. It's gonna be xi sub I plus. Then you're gonna do the g. Okay, so this one is gonna be using those corrections, those first corrections. So these arguments will just be the same ones, but for the function. So it's gonna be the xi correction, yi first correction, ti plus 1, like this. Okay, so now we have this. Okay, now these are the two formulas for the recorrection. And then we might just substitute and get the answer. Let us just do the first one for x. So doing the first one for x, we're going to do, for example, so for this one, like we have said before, this notation want to just adapt because as long as you're consistent, then pretty much everything becomes pretty clear. So if you're gonna do this one here, okay. So for the last one, which is a recorrection, you can just use I plus 1 and not use any C at the bottom. Can even use C2 for correction 1, correction 2. But yeah, according to the course, normally we can just use I plus 1. So meaning that we can just come here for the recorrection, we can just use the I plus 1, provided just there cannot be any ambiguities with any I plus 1. Yeah, because see, for the first I plus 1 predictor, we use predictor. And then now for this one, you can just use I plus 1. So obviously we understand these to mean a recorrection. The subtitle must be part of it just to make sure that no one wonders what you have been calculating here. So we're good. Let us deal with the recorrection. So we're going to do first the x1. Okay, the x sub 1 is the same as this for us. Now, it is x0 delta t out of 2 fx0 y0 t0. x1 corrector, we have that. y1 first correction, we have that, the first correction. And then we also have, when I0 is going to be t1, which we know is already a 1. Okay, so let us see what we can do here. Right, our x0 is a big 1. Delta t is a 1 out of 2. The f, you start with a t. So you start with t0. T0 is 0. Y0, 0. Yeah, that is f, but we start with x0. X0, because it's t, x, y. So x0 is a 1. X0 is a 1. X0 is a 1, yeah? Okay, and then Y0 minus. Then you do Y0, which is 0, like this. Then you have plus. Then you have the F of the X correction, Y correction, T1. Okay, let us deal with the X correction. So the X correction is 3.5. Okay, so yeah, dealing with the F. But you start with the T. So now the T1. Okay, so now what do we know the T1 to be? Okay, yeah, we start with the T1. T1 is a 1. And then we have X also, plus X also. Right, so now the X1 first correction. X1 correction, this is X1 correction. The blue one, it became 3.5. 3.5. So you come here for the X1 correction. Right, so we have exactly that. Let us see, you have the F, which is the 0. T is going to be the T0, which is 0. The X0, which is 1, minus Y0. Let us put some brackets around this to make sure that we can see they go with this. Right, otherwise we can get a bit mixed up. And then now we have the other F, and the F for the first corrector, right, or the first correction. So now Dealing with that one, we're going to have first, according to the F, it's T first. So we're going to have T1, which is 1, plus X1, X1. Okay. Right, X1 for the corrector, remember? Okay, so X1 for the corrector is 3.5. Right, so X1, that is going to be X1 for the corrector is going to be 3.5. And then there is going to be minus Y1 for the corrector. Okay, we check, we've already done it. Y1 for the corrector. We got a minus 3. We got a minus 3. But there's another minus here, but that is a minus 3. So you close like this, and then you can close this way, and then you put a close bracket there. So obviously this is actually an evaluation of this. Let us compute everything we've got. So now within the square brackets, this open square bracket, the closed square bracket, we have a 1, 6.5, 7.5, 6.5, 7.5, 8.5. 1 plus, it appears that we have 8.5. Let's check this out. Okay, you can use a calculator just to make sure that our things are okay and our numbers are correct. One plus 0.5, 1 plus 1, 3.5, and then plus 3, like that. So, okay, let us just deal with this, and then we shall add everything. Right, so that's what I wanted. Okay, yeah, that's what I was saying. So the 1 and the 1 and the 3.5 and the 3, they give us 8.5. 1 plus 0.5 times 8.5, which is 5.25, 5.25, 5.25, yeah? 5.25, 5.25, okay? And then right now, we're going to deal with the next one, which is the recorrection, but we're dealing with the y equation. So it's going to be y at 1, which according to this equation, we're going to have, if it's y at 1 here, it means I is 0 everywhere. So you're going to have y0 or delta t out of 2, x0, y0, t0. x1 correction, y1 correction, t1. Okay, obviously this one is close with it. So y0. So y0, it's 0. Delta t is 1. G, x0, y0, t0. Okay. So now this one is going to be y0 squared minus x0 squared. What is y0 squared? Y0 is 0. But you need to, yeah, okay, yeah. Y0. G has y0, which is 0. X0. X0. Right, so we have x0. Okay, let's deal with x0 squared. X0, yeah. So yeah, x0 is x0 is 1. But like we said, it's 1. The square is on the x, doesn't affect the negative, just so we make sure we get the correct answer. And then now we have the G of the correction things. So it is the correction, etc. So let us deal with that. So, but this one is going to be the y minus x squared. So y first correction minus the correction of the x squared. So it's going to be y first correction. Y first correction is what? Y first correction is -3. Okay, it's -3. So you take the -3. Okay. So minus. So now we have minus the x. Okay. Minus the x of the first correction. X first correction is what? It's a 3.5. X for the first correction is 3.5 or 7/2. So you can write 7/2 if you want. But x must be squared. And then we have this. We have the close bracket there because it's just y minus x squared. We've written that. Okay, now this is equal to, so we'll just use a calculator for this to save time. Let us just use a calculator. So using a calculator, let's see, let us launch our calculator and just do the calculation. So this one is going to become what? Okay, we're just doing this here. So it's going to be like 1/2. And then you do this 0 minus 1. Okay, because if you say 1 squared, it's just the same as 1. So we add. And then now we have -3. Minus. So you have 7/2. Okay. 2. Okay, now let's remove this one and then square. Okay. We have this. Let's see what. Let's check the input. In our calculator, we have this. Okay, so we have the 1/2, 0 minus that. So now we count the brackets. 1, 2. Right, so you have 1, 2, then you have 3. Gonna open. 1, 2, 3. That close. It's my hope that this is okay, but we'll just cross-check. Might give us the correct answer. So it is giving us minus 8.125. Minus 8.125. You see, there are a couple of ways to cross-check this answer. So we can do this. Okay, so you can start from the inside. Like you can say negative 3 minus 49 out of 4. Okay, like this. And then you minus 1. And then you multiply by 0.5. It looks all right. Which is minus 65 out of 8. And it is minus 8.125. So this sort of gives us the final answer for the recorrection. Meaning that at this point, this is the answer to the problem. So think about it and make sure you understand it. One thing with this module, a little bit, it takes a bit of time sometimes to do these things. So it's very important that you have your formulas in order. You understand, you sort of understand them, but also you can be able to remember them. So as part of your summaries, you must just say modified Euler. What are the formulas we need to know? As we've studied those formulas, it will actually make the biggest difference ever in the learning process. Otherwise, then you're going to have a situation where you have right, otherwise I mean you'll forget the formula, so you need to write them down. Okay, let's move to the next question. You need to write them down. Okay, so let's move to the next question. Right, now the next question is the following. Okay, the next question is this method of finite differences. Right, so it is very important that we understand the method of finite differences. We've learned it, but okay, this question came in the November 2023. Okay, so, but obviously said do not solve the equation, but just get the equations here. So let us look at what the kids, of course, students, not really kids, but what the students had to do in November 2023 in as far as this question is concerned. As far as this question is concerned, using the method of finite differences, what exactly had to happen here? So this is what we're trying to make sense of. Right, this is what we're trying to understand. Now, in this case, right, in an attempt to make sure that we understand these, we write the first equation. So we have y double primed x, y primed y, so now minus y squared, 2x, x an element of 0, 2. Right, so now in the end, let us actually ponder on these and make sure that we are able to understand this particular question in the best way possible. Right, in certainly the best way possible. Right, I want us to remember some relations here, and obviously I'm just going to write them down. We actually had a discussion about some relations that are very, very important for us to understand. And at this point, you'd have exactly the following. You'd have exactly the following. Right, you'd have exactly the following. Okay, right, we ponder on these and we try to make sense, but sense of all these. We remember some things. This here, I want to write it as follows. First, what is this? D squared y. So we can write this one as x. D squared y dx squared. Y dy dx minus y squared is 2x. X element of 0, 2. Okay. And then we need to remember some of the equations. And the equations are, for instance, d squared y dx squared is exactly the same as what? It's exactly the same as yi plus 1. Okay, so we use the approximation symbol. So, okay, obviously these are the formulas we discussed last time, but you need to always remember them. So this is minus 2yi plus yi minus 1, which is h squared. Okay. So that now, so whenever we evaluate the y, at xi, it is the same as yi. Right? So you think about this. You think about that exactly. Right. And there are more things. There are more things. Right. There are more things. I want us to. Right. Okay. There are more equations I'm gonna write right now, and we need to make sure we internalize these. I gave these last time in the. We're gonna actually look at these once more today, and make sure that we have a fair understanding of the equations we need to use in solving problems of this particular nature. Right, now we will recall that there is another equation that I wrote, and I'm just going to write it again. So I want us to write dy dx. If this one is evaluated, okay, starting first with just the difference equation associated with these. Right, we actually were able to state some of the equations, and I want us to state them here. I want us to be in a position to state them and say it is yi plus 1 minus yi. Right, minus yi minus 1. You divide by the following. You divide by exactly h. Okay. Now, I want us to think of this carefully because we are starting the method. So we actually are starting with the kinds of equations that must actually then be understood. And if this becomes exactly the case, you would have exactly this here. You would have exactly that. Right, you'd have exactly that there. Right, now there's more I want to write here. There's certainly more I'm going to write just now. Right, there's more I'm going to write in a split second. Right. Right, so there's more I'm going to write right now here in an attempt to make sure that we have every single bit of thing we need. There are more tools that I'm going to note down that we're going to use here in doing this particular problem here. Right, there are more tools we actually will be using in solving this particular problem. And so we pay particular attention to the tools. I'm going to write, okay, just in one split second. In one split second. Okay, there are more tools I will give just now here that will help us to be able to get the answer we need. Right, that will help us to be in a position to get the answer we need. Right, so just a minute. Just one little minute. Just 1 minute. Right, so still here, there are more relations I want to give. There are more relations I want to give pertaining these. So we are still going on with our discussion. I want us to include extra details, but additional details that will be of great assistance. Okay, so just pausing, just in a minute, there are more relations I'm going to actually write here that can help us a big deal. Can help us a big deal. So just pausing to gather more details, and we shall continue just now here in solving this particular problem. Right, in solving this particular problem in a step-by-step manner. Right, so it is standard practice, I wanted to say, it is standard practice, we put the number 2 there. Right, the standard practice, we put the number 2 so that we put the yi plus 1 minus yi minus 1, we put the number 2. And obviously, as we have indicated, we put the square there. That is what I wanted us to actually include as part of what become the strategy for us to solve these particular problems. Now with these, then we're in a position to continue. Right, so let us continue and solve this particular problem in a step-by-step fashion. Right, so in continuing to solve this particular problem, we then say, okay, let's analyze these carefully. Now, we have been given y primed at 2. Right, now y primed at 2 corresponds to what? Right, it corresponds to the first derivative. Right, and we have y primed at 0. That corresponds to the first derivative. So we're going to use exactly this particular result here. But there are two values, extremes of the interval. In other words, our x itself lies between 0 and 2. So we then will take these particular two equations and put them in this equation there. So we have the following. Right, so thus we have y double primed x plus y primed y minus y squared becomes 2x whenever x is between 0 and 2 inclusive. We remember our two equations and we plug them in. So we're going to put this particular one, which is yi plus 1 minus that one. So you have exactly yi plus 1 minus 2yi like this. And we have plus yi minus 1. We divide everything by what? By the square of h. Okay, so obviously this one here gives us the y double primed. Like we said before, if we're evaluating, so we have xi, that's going to be involved. For the x, we have an xi. And then we have y primed, which is exactly this one here, which is exactly the same as yi plus 1 minus yi minus 1. We divide by 2h. Once again, you need to remember these particular formulas. Okay, this is going to correspond to the y primed. Next, we have yi minus. Okay, now we have put the y primed, and then we have put the y, and then we have the y, but the y is going to be for us yi. We square it, and it's going to be 2xi. Right, and with these, we have that x is an element of 0 to 2. Okay, now these exactly are the tools we need, and we'll actually therefore continue to solve this problem. Now, let us think about what we need to do exactly in this case. Right, what exactly we need to do in this case. So with these, we continue to analyze this particular problem in the same way that we normally analyze our problems in this particular case. So as indicated already, we're going to find a series of equations. Right, we're going to find a series of equations like we are used to. And but yeah, we don't need to solve the equations. Do not solve the equation, but we shall find a series of equations. What exactly are the equations? So the way that we find the equations, we'll then say, for instance, what happens when I is 1? Right, so in other words, at I equals 1, you would have what here? And we have that. Obviously, we're putting h here, but you can put delta x. Let's substitute that first. So if delta x is 1, so in other words, it would therefore mean that delta x is h, which is 1. Okay, so we put that everywhere where we see h before we even start playing around with this particular equation. So you're going to have, okay, but if it is 1, then you're going to have yi plus 1 minus 2yi plus yi minus 1. And then we have, yeah, xi plus, okay, it is 1 here, so we're going to have yi plus 1 minus yi minus 1, okay. We have this one here, minus yi squared equals 2xi. Okay, so there's a plus 1 there. In other words, we are effectively then saying we got the differential equation, this particular one. I want us to write this out because we're going to play around with these, but now over a series of steps like we're used to. This is the equation we need. But now we'll just get this equation, and the examiner is clear that we don't have to solve this equation, but we need to determine it. Let's continue. Right, so when we continue, then we shall write the following equation. Let us analyze it. Okay, we shall just take it and explore this equation. So we're going to write yi plus 1 minus 2yi plus 2yi minus 1. Okay, let's see. Okay, obviously we have a 2 here. Here we have a 2. Because delta x is 1, but yeah, you're going to have a 2 there. So that's what I wanted us to write to note. So we're going to have exactly the yi minus 1. So you have yi plus 1 yi minus 1 out of 2. Right, so yi. Yi squared equals, according to these, 2xi. Okay, like so. Okay, so we have exactly these here. We have exactly these here. Okay. Right. We continue with our analysis. We continue. Now, I want us to analyze this particular past exam question and simplify these, add like terms, etc., etc. And as obviously we need to analyze, our x would therefore lie in this particular interval here. Where does it lie? Right, our x, for instance, would lie in the interval 0x to 2. Okay, this is everything we need. This equation is everything we need, but we need to understand that as delta x is actually exactly equal to 1, which is our h, we need to explore that and look at the fact that we're going to have, for instance, x0. What would x0 be? And what would x1 be? So we analyze that, for instance, when I is 1, you would have y2 here, 2y1, 2y0, and put in brackets, and then we have x1. Okay, you can put 1/2 here, y1 minus y0. And then we have y1. Okay, we are putting I equals 1. And then we have y1 squared, and then we have 2x1. Right, so we have this. Okay, now, this is the case when x is 1. But because we're starting from 0, what does it mean? It means that we're going to actually be dealing with, and also these arguments are 0. Means that we actually obviously need to analyze x0. And then if x0 is 0, let us write that one down. Okay, so we're going to start with x0. Because in the beginning, x0 is 0. And then if we look at x1, the next one, when you add, the change is 1, so you add 1. You get 1. x2 is going to be what? You add 1. You get 2. And this would obviously be those values we need. So you're going to have exactly those particular values of x there. Okay. Right. Now with these, as we analyze this particular question, a very, very important finite difference method situation here. Right. A very, very important situation here. Okay, you take note of these because these kinds of questions repeat the most, but we have a perfect opportunity to analyze these ourselves. So let us take our time and make sure that we have a fair understanding of these particular problem here. Right, of these particular problem here. Right, of these particular problem in this case. Okay, so let us reason together and make sure that we are able to understand these very, very well. Okay, I was saying that when I is 1, we have this. And so now, simultaneously, I want us to explore this boundary condition. So we're going to explore also these boundary conditions there that we can use. Right. So now, exploring these are called the boundary conditions. Let's just exploring the boundary conditions because we need to use them. Right. So the boundary conditions would this. Right. So the boundary conditions themselves are associated with what? Associated with the fact that if you have the first derivative at 0, and you also have the y at 0. In other words, this would be at 0, it will be corresponding to y0. And this will be corresponding to, obviously, the question becomes, what is y0? And this would be corresponding to, because when we have x0, it's 0, x1. Okay, the change is 1, so you're going to add 1 to 0. And then you're going to add 1, you get 2. Excuse, because that is 2. Now, the questions these bring immediately are, what is y0? Okay, corresponding to x1, what is y1? What is y2? Okay. These become sort of very, very immediate questions that make us to think, and that we need to make sure we sort of are able to understand, but also are able to interpret. Right, that we can interpret carefully. So we then continue with our analysis and say, for example, we will therefore come to this point and then say, this would be, what would y2 primed be? That becomes a question. But we already know, because if ever the argument is 2, it is x2. And that corresponds to y2. And in particular, it would mean, therefore, y2 primed is 0. It means that y2 primed is 0. Okay, so we are exploring these particular equations, but this would mean that y0 primed times y0 is 1. y2 primed is 0. Okay, let us deal with this. dy dx. Okay, now dy dx is y I plus 1 minus yi minus 1 divided by, so it's yi plus 1 minus yi minus 1, you divide it by 2h. Right, so that is what we're going to put here, but we need to therefore understand that that corresponds to y0 primed times y0 is 1. Okay, what would y2 primed be? It is actually exactly equal to 0. Okay, I want us to consider these particular boundary conditions as important. But also, I want us to look at the former equation we've written. We have a y0, but now whenever we can see y0 primed with y0, the answer is going to be 1. So now you have a y0 that appears here. So if you multiply out here, you have a y0, y1, y1 squared, y0, x1. Right. And so what other equations can be able to achieve out of this? For instance, when I equals 2, what do we get when I equals 2? Okay, because I can be 2, because that is going to give us an x2, and x2 is 2. Okay. But first, we can perform some algebraic simplifications here. What is x1? It is 1. So you can put 1. Right, and therefore, what would y1 be? Obviously, not all these are known, but our y2, 2y1. Two y0. X1. What is y1? Right, and then you have y0. y1 minus y1 squared is 2. What is x1? It is 1, according to the delta H or delta X. Let's simplify these. Right, so we have a y2 minus 2y1 plus 2y0. Okay, so we have this one here. We can multiply out everything. 1/2 y1 squared. Okay, because y1 times y1. 1/2 y0 y1. y1 squared equals 2. Right, so we continue with our analysis of this particular problem here. We continue with our analysis of this particular problem here. Let me see. Okay, just 1 minute. Let me. Hello? Yeah, please, can I call you back in 30 minutes? I'm in class. Okay, thanks, Kaku. All right, Kaku. Right, so we continue with our discussion, and then we have these here. So let us look at these particular equations and see what simplifications we can actually be in a position to do. So when I have, for instance, the following. Okay, I want us to take these equation. I want us to take these particular equation. Right, I want us to take these particular equation. Right, I want us to take these particular equation. We got an equation which is y2 minus 2y1. Okay, we need to analyze and see, obviously, if we can have any right terms in this. 2y0, 1/2 y1 squared, 1/2 y0 y1, y1 squared equals 2 exactly. Okay, yeah, there are some like terms. For example, there is a 1/2 y1 squared and minus y1 squared, so we can add those like terms, but there's only a single y2, so you're going to have exactly a 2y2, 2y1, 2y0. Okay, these two guys, 1/2 y1 squared minus that is minus 1/2 y1 squared. So these like terms, we dealt with them, and minus 1/2 y0 y1. y0 y1. Okay. So this is exactly what we are able to realize. And this is exactly the same as what? It's exactly the same as 2. Right, so now, having obtained that, I want us to take this particular equation, think about it a little bit, make sure that we have a fair chance to understand these. To make it easier, to make it a little easier, I want us to list right. I want us to do the following. Right, I want us to do exactly the following. Okay, I want us to take this one. I want us to do it in a very organized manner. Okay, because this is our main equation. Right, everything we're gonna do is around this one. So let us take this particular equation and play around with it and get all the answers from it. That is the thing. So, and that is the objective. So let us do the following. Let us get the following. Okay, allow us to then say, okay, let's write like this. Yi plus 1. Okay, we have a perfect chance to play around with this finite difference method equation and get the correct answer. Okay, and we have this, and we have xi, and then with 1/2. Okay, we got this one. Okay, but yeah, there's something I want us to do just to get nice little equations out of it. And we don't need to solve the final system of equations, but yeah, we need to just get all the equations. That is the objective, getting all of them. And then with yi squared, which is 2xi. Good. Let us look at this. But I want to write a line. And the line is going to say the grid. The grid in this problem. So you note how we tackle this. Right. So the grid in this problem consists of the following. Of the following points, which is x0. Okay, yeah, x0 is 0 because yeah. So we're dealing with these things between 0 and 2. X0 is 0, and then the delta, the change is 1. So which means that we're gonna do our usual things. What is our usual things? X1, you add 1. You add 1 again, you get 2. Okay. So we have the following. Right. So x2 and then yeah, anyhow, I mean x1. Okay, because x0, x1, x2. Yeah. X1 is 1 and then x2 becomes 2 because we just adding 1. Okay, good. So yeah, so the grid in this problem consists of the following points. Okay, we stop at 2 because it's between 0 and 2. Yeah. Okay, so note that one. Um there's more I want us to say here in this particular problem. What exactly I want us to do it in red. Okay, let's play around here like the examiners would like us to. So we're gonna do first I equals 0. Yeah, let's be organized like this. We're gonna do I equals 0. When I is 0, we're gonna have y1 minus 2 y0 plus 2 y minus 1, and then we have x0, and then we have 1/2, and then we have yeah, we're putting I equals 0, so we have y1, and then we have minus 1, and then we have 0, and then we have 0 squared, which is 2x0. So this is what we get. when I is 0. Y1, Y0, Y minus 1, X0, Y1. Okay, we just check. We're making I equal to 0, so we're getting these things here. Good. Okay, yeah, let us just substitute the i's. And then now we're going to put I equals 1. Okay, if we put I equals 1, what we get? We get it a Y2 because it's 1 plus 1, and then we have Y1, and then we have 2 Y0, X1, 1 half, Y2, yeah, Y2, okay, yeah, and then Y0, because we're putting I equals 1, and then we have Y1 squared, 2 X what? 2X1. Okay, next. Can we put next thing? Okay, we don't need to solve this, but yeah, we need to get all the equations. Let's put I equals 2. Because we must go up to X0, X1, X2. Okay, so we're going to go, and this is still X1, so we need I equals 2. I equals 2 is Y3, 2 Y2, 2 Y1, X2, 1 half, and then 3 minus 1, Y2, Y2, X2. Okay. So we have this. Okay, now let us, okay, these equations are everything. So there must be like 3 of them. Why? Because we go from, if x lies between 0 and 2, then we have x0 is 0, x1 you add 1, and then x2 you add 1 to 1, you get 2. So we stop at x2. So x0 to x2. Okay, now I want us to play around with these, but also with the boundary conditions, and then we're done. Okay, but now we need to be more organized. Otherwise, then we have all these equations that are mixed up and all over the place, and then it's not good. Not good. Okay, now let's us just play around. So we're just playing around with these equations here. So right, we're gonna be moving pretty quickly with these equations. Okay, the finite difference method is there. No doubt, it's there. So you need to make sure you sort of able to understand it. Normally, it comes in several dimensions. Okay, what dimensions does it come in? Okay, we have already said for I equals 0, y1 minus 2y0, 2y minus 1, x0 plus 1 half, y1 minus yi minus 1, y0 minus y0 squared is 2x0. 1 minus 2y1, 2y0, x1, y2, y0, and then y1 squared, 2x1, 2 is y3. Okay, I'm writing those equations we got just now because I just want to organize them very well so that we can get all the answers and then we're done. But obviously, don't need to solve these. Normally, that becomes a strategy because these are like a bit many. And then we have the plus 1 half, y3 minus y1. Yes. Okay. And then y2 squared 2x2. Right, so we have this. Okay, now we're back. We are back. What exactly do we need out of these here? We need to substitute everything. So we take these particular equations, and this is true if and only if we get the next equations. So now let us get the next equations. Okay, now we need to substitute everything and solve. Okay, like the first equation we've already got, the I0. Let's check the first equation we've got. This one. Okay, for I equal to 0, for I equals, that was I equals 1. We have got. So now I want us to simplify the first one. And then the next one we've already simplified. But what about this one? When I is 0, and then we have x0. Easy. X0 is 0, x1 is 1, x2 is 2. But x0 is 0. So this is going to disappear. And then we have x0 is 0. X0 is 0, so it's going to be by 0 is 0. 0. And then we'd have only y is 0. Right. And then you're going to have 1/2 y1 minus y minus 1. And then we have y0 minus y0 squared is 0. Okay. So now, all right, so okay, we have this. Okay, just continue. Now let us find this one corresponds with the first one. Okay, now the I equals 1 we've got is this one. Yeah, I equals 1 became this, and then it substituted some things. And we got to this point. Right, and then we got to this, and that was it. So we take this equation as it is, any like terms, y2 is alone, y1 is alone, y0 is alone, etc. So we take this equation, we're going to take it to the system. Right, we want to form a system of equations. So you have 2y2, 2y1, 2y0, y1 squared, y0, y1 equals 2. Okay, this one corresponds to this one. Okay, and then we got that. Now, at this point, what else do we need? Right, so we'd need the other one, this one. Okay, let us write it here and then see if we can simplify it quickly. So we have x2. X2 is 2. So you're going to put 2 here. If you put 2 here, it's going to be like 2y3, 4y2, 4y1, and then 1/2, yeah, 1/2 y3, y1, and then y2, y2 squared. X2 is what? It's 2. 2 times 2 is a 4. Okay, so yeah, we get this. So we can write let's just write everything. 2y3 4y2, just multiply this by 2 because x2 is 2. And then it becomes multiplied by 2. It's 4y1, y3, y1, y2, y2 squared, 4. 4. Like this. Okay, so now we take this one. What we do is we take this one and then we combine everything. But now we can do a little bit more than this for now. What we can do is we can take these particular equations we've written and do something more with them. Okay, so let us do this. Okay, this is the answer to the problem already, but there is a little bit we need to do about the boundary conditions. But now then we continue and then say this is going to be like the 3 equations. 1/2 y1 minus -1 y0. Y0 squared is 0. Y2. Y1. Y0. Y1 squared. Y0 y1 equals 2. 2y3. 4y2. 4y1. 1/2. Y3 minus y1. Y2. Y2 squared is 4. Okay, let us have this one, but now there's more we need to say. Okay, we save this one for now. We save this one for now. But, and then we now apply the boundary condition. Apply the boundary. The boundary condition. Okay, what are all the boundary conditions, which are 2 of them? They are y primed at 0 and then y at 0. It's 1. Y primed at 2 is 0. Okay, we'll continue, please, with our analysis of this. Using central differences. Right, central differences to approximate. Right, to approximate the derivative. The derivative y primed at 0 at x0 is 0. One can be expressed. Okay. Okay, using the central differences, those equations we have got, using the method of finite differences, we've got some equations, and then we can be able to, okay, the fact that now we have y primed, y2 primed is 0. Simultaneously, we know that dy dx is yi plus 1 minus yi minus 1 divided by 2h. And then this one is going to give us at x what? At x2, because x0 is 0, x1 is 1, and then x2 is 2. Okay, but we're looking between 0 and 2. So this one is going to be the derivative. If we're going to do this dy dx at x2, you can write. We're going to do it at x2. x2 is 2. Right. So at x2 is 2. It means what here? At x2, then it means that because it's xi, so I is 2, which means that it's going to be, if I is 2, then you're going to have 2 plus 1, 3, minus 2 minus 1, 1, 2 divided by 1, and therefore this is equal to 0. Which means that if it is equal to 0, y3 is y1. We get another equation. Simultaneous equations are building up. So whenever we see y3, we can put y1, because that is what this boundary condition is giving us. But we have more. We have more. Right, we look at this one. Y prime at 0. Y at 0 is 1. What would y prime at 0? So you see, when we're dealing with y prime at 0, it means that x is 0. Rather, I is 0. So when I is 0 in the first derivative, I is 0 here, it's going to be y1 minus y minus 1 divided by 2. H is 1. And then we have y0 is exactly this. So which means that there's another equation you're going to get. y1, y0 minus y minus 1, y0 is 1. That is another equation. So these equations are many. So you're going to call this one 1. And you're going to call this one 2. And then you're going to call this one 3. Because this boundary condition produced this and this one produced that. So what do we do now with these particular equations? We need to put them next to each other and analyze and see what we can do. So what we're going to do is we're going to put them adjacent each other, and this is what we do. Okay, so now we're going to be here. So we're going to have this one here. We're going to have exactly this. So we're going to take this equation 1, and then we're going to put them next to each other. We're going to, we look at how we can simplify the things, and then we are done. So this is the finite difference method. It's the kind of method that will surely be there. Okay, this is how it was asked in November 2023. So, right, pay particular attention to what we actually. Okay, yeah, let's continue. So I was then saying that let's just put them next to each other. So we have 1/2 minus y1 minus this one, y0 minus y0 squared, and then 2y2 minus 2y1 plus 2y0 minus 1/2 y1 squared minus 1/2 y0 y1 equals 2. And then 2y3 minus 4y2 minus 4y1 plus 1/2. Okay, these equations we've got already. y3 minus y1, y2 minus that squared, it's 4. Okay. So we continue. We continue. Okay. Okay, now we have this, but these are not the only equations. What else? We also have this one. So this one we called 1. Yep. And then we have 2, this one. y1 equals y3 is equation 2. y1 equals y3 is equation 2. Okay. And then there's another one. This one. y1, y0. y1, y0. y1, y0 minus y minus 1, y0 is 1. Right. Y minus 1, y0 is 1. Okay, we called this one equation 3. Okay, so we have these equations. So now the question is, what do? We need to just simplify and do the best we can. Let's just pause to reason together. We need to perform some substitutions here. Right. Right. So we need to substitute these equations here. For example, so here we can replace the objective of these becomes to replace the negative index. By good luck, there it is, the negative index. So if you multiply here, what do we get? We get y1, y0, y1, y0, and then y minus y1, y0. Aha, this is beautiful, but it is awesome. So now, if you multiply here, you have y1, y0, y1, y0 minus y minus 1, y0. It is 1. So in other words, these other things here would produce a 1 minus y0 squared equals 0. What is the implication of this? This means that is the equation we've got. And then obviously we can do more with it. What can we do with it? We can make y2 the subject, but yeah, we don't need to solve. So, but it is a simplified equation that we've got from this. So this one has been very useful for us in simplifying the first equation. From this, we have that 1/2 equals y0 squared. Now we look at the next one. y1 is y3. y1 becomes y3. Wherever y3 appears, you can put y1. And now, this is because the y minus 1 equation simplified the first one. So this one we can leave. y2, 2y1, 2y0, this one squared, y0, y1 is 2. Okay, y1 is y3, you substitute. So wherever the y3 appears, we're going to put y1. 2y1, 4y2, 4y1, plus 1/2 y3, y1, y1, y2, y2 squared is 4. Okay. So yeah, this equation can be simplified. y1 minus y1 becomes 0. And then, so we have this. And then 2y1 minus 4y1. What is 2y1 minus 4y1? It's minus 2y1. So we're done with this. And then there is minus 4y2. And then we're done with this. And then there is minus y2 squared equals 4. And the instruction is, please don't solve this. The first equation is 1/2 equals y0 squared. y2 minus y1 plus 2y0. y1 squared y0 y1 equals 2. All right. So, well, the truth is these would have to be the equations that we've got. You don't need to solve these, but for instance, you can see that y0 can be solved here. But how many unknowns are these? I mean, we have 1, 2, 3 equations. How many unknowns? There's y0, there's y1, and then there's y2. So obviously these equations can be solved because we have 3 equations with 3 unknowns, right? So we can be able to solve this somewhat. But they said, obviously, please, students, do not solve the equation, but instead, just leave them as they are. So this becomes the final answer, the method of finite differences. It was quite a hectic question a little bit. So I'm sure that you had a chance to take a look at these. As said, really, it's not that we just decided to do this question here. Because the first paper we finished exhausted completely was the January paper. This one is the November 2023 paper. We are trying to exhaust this paper right now. That is what we are doing. We are on a mission to finish like every part of this paper. Most of the things are pretty much already understood. But obviously, there are like some differences I'm sure you can see between the paper we did and this one. The one we finished was the January paper, and this one is the November 2023 paper. Obviously, we're going to continue our discussion even next time to do the next, because it is the end of this question. So this is the answer to this question, and then we are done up to this point with this particular question. I'm using the method of finite differences. The next question is going to be another version of the shooting method, but yeah, as said in the paper of November 2023. So this will be the discussion, but not only shooting method, but also, I mean, there are other questions that are a lot, the paper and beyond, because we are trying to make sure we cover enough ground. All right, this method we did in the beginning today on the modified Euler, the first one, modified Euler, right? It was our first time to do the modified Euler, like very, 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 very first time. Okay, so but we have a chance. This method of finite differences was obviously an extension of what we know, because we actually dealt with a similar problem in the past, in one of our discussions, but this actually cropped up. So I'm sure that it was very, very profitable for us to discuss this particular problem. I must indicate that it was very, very profitable. So what are you supposed to do? You need to take this particular method of finite differences. There are like 2 or 3 more questions we've done. Okay, but obviously there's some differences, but this one is similar to one of the questions we did. So you compare these 2 methods, you put them next to each other, you write the formulas when you need to use here, and obviously you go through the technical steps to see exactly how this problem, the mechanics of solving these works. I think that it was an interesting discussion because we are a bit beyond the time by a couple of minutes, but we shall continue our next discussion and do more of the APM. Okay, the other things that we're yet to do. Yeah, but obviously we're going to finish the paper of November, and other sections will be discussed as well. The Liebman's method will also be I'm sure be visited. Right, we must thank you for joining us. It was an interesting discussion, but yeah, we actually, I'm sure, learned a thing or two out of this paper. Right, until next time, we know when to meet again. Thanks a lot. Take care and goodbye, and God bless.
Thank you. Goodbye.
Thanks. Goodbye.